Okay. Hi, everyone. Thanks for coming. I'm really excited to talk to you today about how we can enable open publishing by building open tools with open communities. So clearly, I'm in the right symposium. I've said open 3 times on my title slide. But first, I want to talk to you a little bit about publishing, specifically what publishing looks like today. So let's just go ahead and say it. You and your colleagues have designed a study, collected data, analyzed the results, and written a paper. It sounds so simple in a sentence, but we all know it's not. This is science. So you've gone through all this work, you've written this paper, and now what do you need to do to get it published? Well, first, you need to send the paper to a journal. Then you need to wait on that journal editor to find suitable reviewers. Then you need to wait on those reviewers to provide revisions. Then you need to address the revisions and resubmit. And as someone who's gone through this process, there's definitely a little bit of iteration between revisions and resubmitting a couple of times, let's say. And finally, you can correct the final proof and publish. And this is really great. This has served us really well for quite a while now. But there are a lot of people who are realized that if you look at these steps, there's quite a bit of waiting. There's waiting on the editor, waiting on the reviewers, and then the waiting that goes back and forth as you're iterating on the revisions, right, and the resubmission. So a lot of folks have looked at this and said there must be another way. And the way that was first found, and I think makes a good deal of sense, is to just go ahead and send the paper and publish. And what that really means is to submit it to a preprint server. So you may know these as archive, bioarchive, sciarchive. They're all different ones depending on the domain that you're working in. But this is the idea that at the same time that you submit to a journal, you'll also submit to some preprint server and have your work available to your colleagues right away there. And this is not just for altruistic reasons. So Nico Krieges-Korte in 2016 actually published this Selfish Scientist's Guide to Preprint Posting. He even gave a timeline of the best time for you to post your preprint in order to kind of get the most advantage out of preprint posting. And not only for the individual, but for science as a whole, it seems like preprint posting, making these publications openly available, is really valuable. So just in eLife, just a couple of I guess years ago now actually, there was a quote from Jeff Leake that said, if you want to be 1 year behind, don't read bioarchive, right? So there's a lot of stuff that's really happening. It's moving very quickly. It seems like making this information available is really making a difference both to individual scientists and to the field. So it seems pretty clear right away, just from thinking about this, that open publishing is creating findable and accessible science. But as you may remember from Greg's talk, there are a few more letters in the FAIR acronym, right? So if we look at FAIR, we can see that we have findable and accessible down, but what about interoperable and reusable? What would that really mean for publishing? And I think to do that, we need to think about, what is publishing? What is interoperability? What is reusability in the context of a publication? So to do that, I want to go back to my little timeline of how we publish a paper today. And I want to really highlight one piece, which is that I tell you that this whole timeline is publishing today, but then at the end, I have this magical word, and publish. So what is publishing, right? Like, it seems to be kind of a nested problem. The whole process of publishing ends with publishing. So what is it really? And if we look back, this idea of publishing is one that we've had for a really long time. And it's really built around physical paper. So the way that we read it today most often is actually on a computer screen, so electronic representations of physical paper. But it's really built around physical paper. It's built around static things that you can stack on top of one another. And this kind of framework makes it really difficult to think about what is interoperable and reusable about physical pieces of paper, right? Like, we do get the ideas, we get the methods, we can build on our colleagues' work in this way, but it would be really amazing if we could build on their work directly by actually having these objects that we can directly interact with and extend and make interoperable. And the other side of this that I think is really important to notice is something that's actually pointed out in this lovely piece in the machine learning journal Distill, where they point out that because we're just stacking physical paper, if not literally, then figuratively, we're creating mountains of research debt, really. It's hard to synthesize, it's hard to extend, it's hard to see exactly what's happening across all these different pieces of information. And there are lots of ways to try and think about this, but really by changing the unit of the publication, there could be a really powerful way to tap into making this more extensible. And so just to really hammer home this point, I want to share with you this quote, which I have on screen, but I'll go ahead and read to you, which is, "An article about computational science in a scientific publication is not the scholarship itself. It is merely advertising of the scholarship. The actual scholarship is the complete software development environment and the complete set of instructions which generated the figures." So I think we can all agree that this sounds really wonderful, but this is not quite where we are today. So the question that I've been thinking a little bit about is, how do we get to fair publishing in today's landscape? What would it look like? What would it take to get us so that we have not only findable and accessible results, but also really interoperable and reusable ones for our publications? And to do that, I kind of want to point to a case study of another community that actually intersects with our own and that I found really, really valuable in their approach to tackling these questions. So the Jupyter community defines itself as a community of people and an ecosystem of open tools and standards for interactive computing. And they really kind of hammer home this community point because there's a really broad base of contributors from all over the world. So these are not in one institution, they're not even in two institutions. They're in a number of institutions. And because of this, they have quite a few perspectives. They have many different scientific fields working on this problem of how can we create computational tools that are useful for scientists generally. And the other piece I wanted to point out is that it's a really open community, so they're always looking for new folks. We have a little Uncle Sam here, which is an American reference, but they're just trying to get new people in the room and new perspectives because that will really extend the tools and has been shown to do so repeatedly over time in really valuable ways. So because you have all these different people from all these different places with all these different perspectives, there's a really strong emphasis on creating things that are language agnostic and modular. And this means that even though I code in, let's say, Python, and my colleagues code in R, and my other colleagues code in MATLAB and Octave, we can all take advantage of this infrastructure to support our results. We're not tied to any one tool, we're not tied to any one language, and because it's modular, we can build on things in a way that can create some really amazing results, and it allows us to use all of these other open tools because they can be integrated within this system. So this sounds really amazing, right? This sounds like an open community where people are working together, they're creating modular things, but I promised you we're going to talk about publishing. So let's think for a second about what can this kind of community enable? How could it be useful for thinking about how we can get to interoperable and reusable publishing today? And to do that, I kind of want to trace through some of the different tools that the Jupyter community has developed. And these are not just any one set of people. Again, these are overlapping and intersecting sets of people have developed these tools. But because they're open, both the communities and the tools, people have been able to crosstalk and to really create these different objects in a way that flows really naturally. So perhaps the thing Jupyter is best known for, and which some of you in the room might be familiar with, are Jupyter notebooks. So these are a really, really amazing tool if you haven't had a chance to play around with it yet. But basically, it's a way to intersperse narrative text, code, and outputs. So you can really write a full paper in a Jupyter notebook because you can have all your text, all the code that's used to analyze your results, all the code that's used to generate your figures, and have it all in one place. This is really cool. But it doesn't quite look like a paper. It looks like a notebook, right? That's the name. It's supposed to be a notebook. And so folks have looked at this and said, this is amazing, but I want it to look a little different. I want it to work slightly differently for me. So another set of folks came in and they said, all right, well, what if we did Jupyter books? So we're taking the notebooks and now we're turning them into books. And this is an example actually from Luke Chang, who's a professor at Dartmouth, and he created the Dart Brains resource, which is actually a whole textbook of introduction to fMRI preprocessing. So here what he's doing is he's interspersing the code for actually doing his analysis, the result, and then some text explaining what people can see on the screen. And because of the way this is set up, he could actually hide the code, people could collapse and expand it, so it really looks more like a paper that you'd read, but it has all of that built in right away, so you can right away grab the piece that you need and extend it as you need it. So this is pretty cool too. But if we think back to that quote that I shared, one of the things that we're still missing is the environment that was actually used to run the analyses. And so a separate set of people still within the Jupyter community have come up with what they call Binder. So again, kind of binding notebooks together. It all works in different puzzle pieces. So here, what you can do is you can take a collection of Jupyter notebooks, or actually one Jupyter book, and you can turn it in completely interactive. So by providing the requirements that are needed to execute the commands, and by providing the notebook or the book itself, you can just run it right away in your web browser. So you have access then to go in, to manipulate the code, to change different things, and to ask questions of your colleagues' data or your own data when you're coming back to it in a way that's really powerful and allows you to see exactly what they saw when they first designed the analysis. And so these all are amazing pieces that have come together because different folks within the Jupyter community have taken this on and said, this is something I need for my use case, this is something I would like to have, how can I make this happen? So one effort that I've been involved in is actually kind of tying some of these pieces together. So using Jupyter Books and Binder running on Compute Canada, we've been creating this new initiative, NeuroLibre. So there are way too many people to list, but I do have some names on the slide. And the goal is that we'd like to have a way to have a curated set of notebooks for neuroscientists to either share the results or share tutorials and have the computational infrastructure backed by Compute Canada so that you could come, you could interact with these, you could learn through these, or you could use them in your own courses in a way that's, I think, really powerful and really exciting to kind of change the way we're teaching and interacting with science. And then building a little bit further, there's an initiative here in the OHBM community, Aperture, where the goal is to host novel research objects such as NeuroLibre notebooks. So here they would go through, just like a scientific publication, they would go through review, they would be vetted, and they would be published to the community as an Aperture object. But not only now would they be PDFs, they would now be the full interactive kind of pieces or data sets, code that we really need to have interoperable science, because you're no longer just looking at a PDF. Now you're looking at all of the pieces that support it, and you can take what you need for your own work to build on your colleagues more directly. So with that, I just want to say thank you to my supervisor, JB, to Chris Holdgraf, who was my introduction to the Jupyter community and is an amazing resource, to the entire OpenSig community, to the entire NeuroLibre team, and my funding. And then I wanted to leave you with a few take-home ideas.